The formal definition of non-deterministic finite automaton, or NFA, is pretty similar to that of a deterministic finite automaton, or DFA. Both have set of states, the alphabet, and the set of accept states. And I clearly dodged the transition function because it looks very different. I've also dodged the point about single start state because I've shown you earlier that with epsilon transitions, you can sort of have multiple start states. But anyways, the important thing to discuss here is the transition function. So let's shift our focus to that. In the DFA, the transition function takes a state and an input symbol and produces the next state. In an NFA, the transition function takes a state and an input symbol, or the empty string epsilon, and produces the set of possible next states. The key term here is the set of possible next states. Given finite set of states Q, how many sets of possible states can the NFA transition to? To enumerate all the sets of possible states, we have to evaluate the power set of the states in Q. If the set Q has n states, the power set of Q has 2 to the power n sets of states. Here is an example. Q is a set of states Q1, Q2, Q3. The power set of Q has 8 sets of states in total, which also includes empty set. Alright, now let us consider this NFA and come up with the phi tuple that formally describes it. First, let us list the set of states of this NFA represented as Q. Then the alphabet sigma. And then the transition function delta, which maps the Cartesian product of states and the alphabet augmented with empty string epsilon to the power set of states Q. Looking at the state Q0, it is clear that it loops back to itself when the input symbol is 0. As the range is a set of states and not just states, we have braces around the state Q0. When the input symbol is 1, it loops back to itself as well as transitions to Q1. So we can write it out as a set with states Q0 and Q1. For empty string, there is no transition, so we map it to the empty set phi. Similarly, we repeat it to Q1, Q2, as well as Q3. I will let you observe the results I put out in the transition table for a bit. Look at the NFA and the transition table to make sure everything here makes sense. Alright, and then we have the start state, which is Q0, and the final and accepting states, the set F, is just, it contains only one element, which is Q3. There you go. Here is the formal phi tuple definition of the given NFA.